Hi friends, we'll solve problem on curvilinear motion. You see what is given in problem. Position vector of particle is given by r bar equal to 2t square I plus 4 upon t square j meters. Determine when t equal to 1 second magnitude of normal and tangential components of acceleration and radius of curvature of path. As r bar is given in terms of ij unit vector, where r bar is always expressed as what? Xi plus yj. That means here as r bar is given as 2t square I plus 4 upon t square j, r bar is always expressed as xi plus yj. That means x is what? 2t square and y is nothing but 4 upon t square. Therefore, if we write here x is what? X is 2t square. Say equation number 1. Differentiating equation 1 with respect to t, we will get what? Dx by dt. Dx by dt is nothing but what? Component of velocity along x-axis, which is equal to differentiation of 2t square is what? 4t. This is equation number 2. If we differentiate again equation number 2, that means Vx with respect to time t, will get component of acceleration along x-axis. Differentiating equation 1, if we differentiate dvx by dt, this is ax which is equal to 4. This is the equation number 3. Similarly, as x is 2t square, y is equal to 4 upon t square. Say equation number 4. If we differentiate equation number 4, means y with respect to time t, what will get here? Dy by dt, which is equal to Vy. Now if we differentiate, so this one is 4 into t raised to minus 2. That means minus 8 into t raised to minus 3. This is equation number 5. Again, if we differentiate velocity component Vy with respect to time t, what will get here? dVy upon dt equal to minus 8 into minus 3 comes out to be 24 and t raised to minus 3 minus 1, that means minus 4. This one is equation number 6. Now you are getting equation of Vx and Vy, equation of Ax and Ay. You have to find out normal and tangential component of acceleration at t equal to 1 second. So first we will substitute t equal to 1 second in equation 2, 3, 5 and 6. We will find out Vx, Vy, Ax and Ay. From that one resultant velocity will get, resultant acceleration will get, their magnitudes and acceleration. That means in next step, let's find out Vx, Vy, Ax, Ay at t equal to 1 second. You see on next page, at t equal to 1 second, at t equal to 1 second. Now we'll get Vx. Vx is equal to, see formula of Vx, what we have done here after differentiating is 4t. That means 4 into 1. So this one comes out to be 4 into 1. That means what? 4 meters per second. Answer positive means rightward. Similarly, Vy. You can see Vy equation, what we are getting here is minus 8t raised to minus 3. That means if we substitute here values, what will get here? Minus 8 into 1 raised to minus 3. That means from this one, this Vy comes out to be minus 8 meters per second. Negative sign represents what? It is 8 meters per second. Y component, that means what? Downward. Now Vx rightward, Vy downward. From this one, resultant velocity comes out to be in 4th quadrant. Graphically, if I'll represent here Vx rightward, Vy downward as it is. That means what we'll get here, this is resultant velocity V. This angle is the theta, means with horizontal suffix V. That means inclination of velocity with horizontal. This component is Vx, this component is Vy. To find out V, we will use Pythagoras theorem. Square root of what? Vx square plus Vy square. Now if you substitute your values of Vx and Vy, square root of 4 square plus 8 square, so final resultant velocity of particle, if you calculate using calculator, this one comes out to be 8.944 meters per second. Then we'll find out what is the inclination of velocity with horizontal. So this angle, if you want to find out, it is tan of this angle is opposite upon adjacent. Opposite to angle is what? Vy, y component. Therefore theta v is what? Tan inverse of Vy upon Vx. Therefore this one is a tan inverse of Vy. Actually Vy you are getting negative answer. Considering negative sign, already you are represented graphically. That's why you are getting velocity in fourth quadrant. Therefore while finding this angle theta v, negative sign will not consider, because already considering sign we are represented velocity in downward direction. Therefore here only magnitudes of Vy and Vx will substitute. Vy is 8 and Vx is 4 meters per second. From this one, angle theta v, this angle comes out to be tan inverse of 8 by 4 is 63.43. Now you are getting velocity, resultant velocity 8.944, and what you are getting here, angle theta v 63.43. This is at 1 second. Similarly, at 1 second again we will find out ax and ay, resultant acceleration and its inclination. Let's see on next page. Again at t equal to 1 second, at t equal to 1 second, component of acceleration along x-axis ax. Let's see what is the equation of ax. Already you derived and you are getting ax. Now ax, what you are getting here is 4, which is independent of time. That means at any time instant this one remains constant, but v dvy by dt, that means this one is ay. Substituting here t equal to 1 second, we'll find out acceleration component. At t equal to 1 second, ax comes out to be what? Ax is what? 4 meters per second square. Answer positive, means rightward. Ay equal to, now ay is what? 24 t raised to minus 4. That means this one comes out to be 24 meters per second square. Answer positive, that means what? Upward. Resultant acceleration from these components, if you find out, ay, what you are getting here is vertically upward, ay. Ax, component of acceleration along x-axis, rightward. That means resultant acceleration, if you find out, resultant acceleration will get in first quadrant. This one is resultant acceleration a, and its inclination is what? Theta a. Magnitude of acceleration is, applying Pythagoras theorem, ax square plus ay square. If you substitute here this both the acceleration component, what will get here? Acceleration of particle is the square root of 4 square plus 24 square. If you calculate using calculator, this acceleration a comes out to be 24.33 meters per second square. Inclination, if you want to find out, again tan of this angle is opposite upon adjacent. Opposite means vertical is ay, adjacent is what? Ax. That means inclination of acceleration with horizontal is tan inverse of ay upon ax. If you substitute your values, what will get here? Tan inverse of ay value, what we are getting is 24, divided by ax is 4. That means angle theta a, using calculator if you calculate, comes out to be tan inverse of 24 by 4. This angle is 80.54 degrees. Now you are getting resultant acceleration in magnitude and direction. resultant velocity also you are getting in magnitude and direction. During motion, velocity is always directed along tangent to the path. Therefore, will represent now velocity and acceleration passing through same point as per the direction. Theta V angle is very important because it represents what? Theta V, inclination of velocity. It also represents inclination of tangent. Now both the vectors will represent passing through same point, and from that one we'll find out components of acceleration along tangent and along normal. Now along tangent and normal, if you find out, what will get just here? First one, velocity, component of velocity. Velocity is inclined at 63.43 and in this quadrant, where this quadrant is what? Fourth quadrant. That means initially if I'll represent here velocity, this one is say point, this line I'll represent here reference line, and inclination of velocity is 63.43. That means this is a direction of velocity where inclination with velocity with horizontal is 63.43 degrees. This is velocity. Now velocity is always directed along tangent to the path. Velocity is always directed along tangent to the path. Therefore, once we'll represent velocity, this line also represents a tangent. Therefore, we'll represent what? This line as what? Is tangent. That means here I'll add this one is tangent to the path. Next, resultant acceleration what we have calculated, that one also will represent passing through same point, right, where inclination of acceleration is equal to what? 80.54 with horizontal. That means nearly you can say vertical. This acceleration I will add here with vertical angle is 80.54. That means if I will represent, this one is the acceleration A, where this angle is what? 80.54 degrees. Now as you are getting here 80.54 and 63.43, these are the inclinations. To find out 80 and AN, what we'll do, we'll resolve these velocities. Acceleration what you are getting is resultant acceleration. If we'll resolve acceleration along and perpendicular to velocity, along velocity means along tangent, we will get tangential component of acceleration. If we'll resolve it perpendicular to velocity, that means along normal, we will get what? Normal component of acceleration. Now how will resolve? So you must know what is inclination of acceleration with, maybe you can say this velocity on this side you find out, on another side. You know this angle is 63.43. This angle is 80.54. That means this angle, if you find out this angle, how will get this angle? For that one, total angle is 180. That means this 180, say this angle is alpha. Alpha, if you try, can you say it is 180 minus this 80.54 minus this 63.43. Now this angle comes out to be what? This one is 36.03. Once we'll get this angle, now if we'll resolve, the first component you can say I'll draw here a line which is perpendicular to tangent. That means this line represents what? This line represents normal. This line is what? Normal. Already you are getting one line as tangent. From this one, if we'll draw here perpendicular, here I will draw perpendicular. Now this component along a normal represents what? Normal component of acceleration. Other component what you are getting here represents what? Tangential component of acceleration. In any such problem, always will represent what? Resultant velocity and resultant acceleration passing through same point. Velocity also represents same as that of tangent. Inclination of velocity and inclination of tangent same, because velocity is always directed along tangent to the path. Therefore, we'll extend same line of velocity, we'll get tangent. We'll draw perpendicular to tangent, so what we'll get is normal. Once you will get resultant acceleration, resolve resultant acceleration along velocity and perpendicular to velocity, you will get what? AT and A. Let me see here. This component of acceleration along tangent, what we are represented here, AT. Now this angle is alpha. That means can you see it is A cos of alpha? So resultant acceleration into cos of alpha. Resultant acceleration already you have calculated where it is 24.33 and this cos of angle is 36.03. Therefore what will get here? Tangential component of acceleration. Using calculator, if you calculate, this answer comes out to be 19.67 meters per second square. So this one is your first answer, tangential component of acceleration. For normal component of acceleration, it will resolve. Now this angle is with tangent to 80 is cos, other component becomes what? Sine. That means an equal to a sine of alpha. That means 24.33 sine of 36.03. Therefore, an normal component of acceleration, if you calculate, comes out to be 14.31 meters per second square. What will get? An is normal component of acceleration. Third part is what? Find out radius of curvature of path. To find out radius of curvature of path, you know rho is given by what? V square upon an. Now you know velocity already calculated. Velocity is 8.944. Let's check. This one velocity we calculated. Vx4, Vy8, therefore resultant velocity 8.944. That means this is 8.944 square divided by an value is 14.31. Therefore, rho comes out to be, if you calculate, 5.59 meters. So this one is your last answer. Before that one, 80 you are getting and an you are getting. Thank you.